hurt, completely defeating the purpose of throwing something at me.
Whatever.
Not whatever. It is your lazy attitude that is at fault for nearly everything these days. I am losing tolerance. To start, how fast do you think that coin was going?
Don't know.
Not fast enough. Do you even know how to calculate its velocity?
Why would I care?
You're my subordinate. If I say you should care, you care.
Okay, fine. So what am I supposed to do?
Well, first, even you understand what speed is, right?
Yeah, it's how fast something goes.
Yes, velocity is similar. It is how quickly, to be a bit more specific, in how little time, something moves from its starting position.
And that means?
It has a direction. Do you understand what I'm saying?
Sure, whatever.
Don't you whatever me. So stay on track. We still have to calculate the velocity you threw that coin. There are several equations that we could use to calculate velocity, but the best in this case is d equals 1/2 v sub I plus v sub f times time. The d is displacement, or how far the coin went. We were standing 12 feet apart, so that would be the displacement. V sub I is the initial velocity, or how fast it was moving at the beginning of the situation.
It wasn't moving begins.
Exactly! See, even you can think, if you try, since at the very beginning you had not thrown the coin yet, the initial velocity is 0.
That's nice.
V sub f is the final velocity, or how fast the coin was going when it hit me. That's what we're trying to figure out. T is time, or how long the throw took, in this case 1 second. Now we solve the equation.
So it's going 12 feet per second. What next, oh great Yama?
How about me throwing you into hell for your apathy? But my job aside, just knowing the velocity is not terribly informative. While we're talking about velocity, I might as well explain momentum.
Which is different how?
In that it takes mass, which isn't quite weight, rather the amount of stuff and things, into consideration as well. It is also interesting because in a closed and isolated system, for instance, if this room was the whole world, the total momentum is always the same. That is not true for just velocity.
So momentum's stubborn and just doesn't go away.
As long as you know what system you're talking about and keep it close and isolated.
Okay.
Momentum is easy to calculate. It's just the mass of the object that changed its velocity from the start to the end of the situation.
Wouldn't that just be the velocity?
Yes, since it started out as 0. And the mass of this coin is 5.7 grams, so the momentum is 68.4 meter-grams per second.
And why do we care?
Because this is approaching the part where I get to yell at you for throwing poorly! That part is called impulse, and it's what changes the momentum of an object.
But I thought momentum stayed the same.
Across an entire system, yes. Within just one object, no.
Right, but why does this mean you're going to yell at me?
Because impulse is also known as force times the change in time, and believe me, the change in time matters. Just think of what happens if you fall and land on something. Would you rather it was a nice cushion or a concrete floor?
Cushion, duh.
But why?
Because it hurt less.
And why do you think that is?
Because it's a cushion?
You have no clue, do you?
As if I care.
You do care, you apathetic failure of a death god.
Why?
Because I said so.
Well, let's be able to land on the cushion then.
Because the impact takes more time.
But if impulse is force times time, wouldn't that just make it bigger?
But you must remember, impulse is the same as the change in momentum. If you're falling, your momentum is the same whether there's a cushion or concrete a few feet beneath you.
Change time, wouldn't that change momentum? This does involve an equal sign, right?
The momentum's the same, which means the overall impulse is the same too. This means that if the time becomes bigger, the force will be smaller, meaning it'll hurt less.
Okay, cool.
This also means that if you throw something quickly, you don't have to put as much force behind it to have it hurt. Or if it's both quick and forceful, it'll hurt a lot, which your pitifully throw slow didn't. And I can show it.
How?
Well, let's find out its force. Force by itself is mass times acceleration. We already know the mass. And acceleration is simply how quickly something gains or loses velocity.
How fast it gets faster.
Exactly, or the change in velocity divided by the change in time, which would be 66 feet per second squared.
And that times mass is 342 feet grams per second squared.
What a breakthrough! My failure of a subordinate can multiply two numbers together.
Are you ever not displeased with me? Actually, are you ever not displeased with anyone?
No.
Maybe if I hit you with this hard enough, you'll change your mind.
Ow! I really shouldn't have taught you that, should I?
That was an energetic throw, huh?
Speaking of energy,
Oh, I thought we were done.
consider this your punishment for hitting me. Kinetic energy is also known as the energy of motion.
Yeah, I would have guessed.
In the same way impulse is the same as momentum, kinetic energy is the same as work. No, not the kind of work that scares off slothful imbeciles like you. This work is force times displacement, basically how much effort you put into moving something.
So it is similar to work done as in a job.
So as you do work, the kinetic energy of what you do work on is changed. So as you did work directed towards me by throwing that coin, the coin increased in kinetic energy.
So what is kinetic energy exactly?
Do I sense interest? Kinetic energy is half of mass times velocity squared.
So it goes back to how fast I threw the coin. Throwing things fast really is important, huh?
It is. And of course, in a Danmaku battle, throwing projectiles quickly makes them even harder to dodge.
Well, thanks for teaching me that. I need to go take my 6th nap for the day, so see you later.
Goodbye, you stupid slothful subordinate.